So this is one of those very specific brackets. So first we need to remove a little bit of support material, and because I use tree support, that is relatively easy. I'm going to be using this to attach this battery plate to the optical tube of my telescope to power my dew heater. Now, through the magic of parametric design, you can change the size of this, you can change the belt width, you can change the diameter of the curvature here. This is a 4-pointed nut. You could change it to a more standard 6-pointed hex nut, and the hole would change to a 6-pointed hex nut hole. Now, the plastic at the bottom of that bolt hole is only a couple of millimeters thick. Because I don't want this ripping out, I want to anchor the nut to the side bits as well. So I'm going to be using some super glue on the side bits to really make sure this nut doesn't come out in either direction. So I'm just going to use this bolt. It moves freely in and out to pull the nut into place once I get the glue on it. And so I can test the fit by pulling it in. And we also want to make sure this guy fits below the plastic here, so we don't scrape our optical tube. Alright, so I dry fit that before I put any glue on, just to make sure it's slightly below the surface of the plastic here. Now you could also put just a piece of tape over the top here before you attach this to your telescope. And ideally, we do not want to glue the threads of this bolt into the nut. Now this nylon strap is going to go on here, and you might notice we're going to need to poke a hole through the center of the nylon strap because it goes between the bracket and this top plate here. And so I need to poke a hole in the appropriate location on that strap with something hot. Probably I'll heat up a bolt and poke through the center. So this is going to be strapped around the back of my optical tube assembly here. You can see that's where the bracket's going to be approximately, and it matches the curve of my telescope. And this strap just goes all the way around, and it just has the buckle. I just throw it at the top up there. So really I just need to get this hole approximately the right distance from that buckle, and the strap can rotate around, so if I need to move this left and right, up and down a little bit, I can move the whole strap around a little bit. So I'm mostly trying to figure out that distance. Also, I have a little excess strap here, and so I'm going to cut it off pretty close to where we're going to be connecting it up here, and just kind of heat cutting the thing so I don't have this thing flapping around a lot. Now, why have I picked that particular location? Two reasons. One is that it's a direct shot with the power line from there to there, so I don't have my power line snaking through the fork and having to move around and everything. Also for balance, because this guy adds some weight to the front of my scope. That's as far back as I can get it to balance that out a little bit. Not fully, but mostly. You might ask, well, why is it not directly on the bottom? Why is it kind of offset to the side? And that's because I put a Telrad sighter up here, which adds a little weight, so now my fork goes that way a little bit. So by having this down offset on the other side, it's going to balance the fork in this motion as well. So the location is chosen mostly for balance reasons, but also for cable routing. So I put a dot in the right spot there. I cut this off with just 1 inch to spare. Now, if you have a soldering iron you don't like and you want to get a whole bunch of black plastic residue on it, you could just poke a soldering iron through here. I'm just going to try to heat up this bolt, because if it gets really horribly sticky, I can throw out the bolt if I need to. I'm just kind of eyeballing this. Oh, that looks pretty good. Alright, so there's our hole. Alright, so paying close attention to the orientation of my buckle and the fact that I want the 12-volt outlet pointing that way, I am going to put this guy through that hole, kind of line this up on top of the 3D printed thing, and then take this screw and attach it to the bracket underneath there. And they have this turnbuckle thing you can turn by fingers, but it's really not that easy. But there you can see I kind of have it lined up on the bracket. I am going to slide it just slightly this way so it's lined up a little bit better, because this guy slides back and forth. And then I'm going to get a screwdriver to tighten that up just a little more. Keep in mind it's, you know, a piece of plastic, so you don't want to tighten it too much. But there, now it's pretty much solidly on that strap. Alright, so now it's just a matter of wrapping the strap around everything where it needs to be, getting the bracket mostly in the place I want it. Alright, I have this tube up this way, and so now if I push it one way, it'll push and stop. If I push it the other way, it'll push and stop as well. And so essentially it's basically balanced around the rotational axis now. Not perfectly, but close enough. While doing this adjustment, you have to make sure you still have clearance to go by your fork there. Now I still have a lot of excess wire here, so I'm probably going to be wrapping that around the end of the optical tube once or twice before it comes back here. So as it turns out, if you wrap this AstroZap cable around the optical tube once and then pull it back to here, it kind of fits right to about there underneath that strap. And so I have my own little cable here that connects into that and then can loop around and plug into this 12-volt hole right there. So that's a little more than I'd like hanging around there. You could, you know, shove it through something like that if you wanted to, or just shorten that cable. I put that optical tube full 90 degrees so you can see the bottom side of it. Basically, the cable from the AstroZap comes out there, it wraps around one time, then it comes back here, goes under the strap, and then it connects to my little adapter cable. I can shorten that cable up if I want. I just have it looped through the handle and then back into the battery plate. So anytime I want to turn on the dew heater, I just take one of these NP-F970 batteries and I put it down into this plate and push it in until this thing snaps, and then that battery is locked in there. And at that point, if I wanted to, I can rotate completely through the forks. And that's the optical tube in my normally stowed position. So when I'm observing, this will mostly be down low unless I'm going up really, really high. I have two of these batteries and a fast charger. It looks like I can use this for somewhere between 6 and 8 hours just for my test last night. So I expect one will be enough, but if not, as soon as I see that I'm down to like one dot, or if, you know, the last dot goes away, I can just push the release button, pull this out, swap it in for another one.